Hello, and welcome to our lesson on recognizing the form of a straight line graph and its basic properties. Today we are going to deepen our understanding of linear equations by exploring how they are represented graphically. This will not only reinforce your existing knowledge, but also enhance your ability to solve more complex mathematical problems. Here's our roadmap for today's lesson. We will start by identifying the basic form of a straight line graph. We'll learn to recognize lines on a coordinate plane and understand their key characteristics. Next, we'll discuss the essential properties of straight line graphs, focusing on aspects like slope, also known as the gradient, and the y-intercept. Finally, we'll work through several examples to apply this new knowledge and solidify your understanding. In our previous lessons, we've already covered some essential concepts. For example, you are familiar with straight line equations and have previously understood their general form, y is equal to mx plus c, where m represents the gradient and c represents the y-intercept. We've also discussed how to calculate and interpret gradients, giving you a solid foundation in the basics of linear equations. If you need further revision on these concepts, then check out the videos on Introduction to Graphs in the Relationships and Change unit. With this foundation, we can now venture into recognizing the graphical form of these linear equations. This skill is crucial because it allows us to visually interpret and analyze data, understand relationships between variables, and solve real-world problems. For example, imagine you are tasked with finding the point at which two different rates converge, such as determining when two competitors will break even in a business context. Knowing how to interpret and work with straight line graphs allows us to pinpoint these intersections quickly and accurately. Now let's get started on our journey to mastering straight line graphs. Let's dive into the main body of today's lesson. We'll begin by working step by step through some simple line graphs to understand their forms. Firstly, we want to be able to recognize simple line graphs. Let's start with three basic equations of straight lines. Y is equal to 2x, y is equal to x plus 5, and y is equal to 4x plus 7. We'll plot these graphs on a coordinate plane. Here's a brief description of each. The line y is equal to 2x, passes through the origin, 0, 0, and increases with a slope of 2. This means that for every unit increase in x, y increases by 2 units. The line y is equal to x plus 5 has a slope of 1 and intersects the y-axis at 0, 5. The line y is equal to 4x plus 7 has a steeper slope of 4 and intersects the y-axis at 0, 7. Let's now begin to think about what these equations and their graphs have in common. For example, they are all straight lines. Furthermore, they all have the form y is equal to mx plus c. Here, m represents the slope or gradient of the line, and c represents the y-intercept, which is the point where the line crosses the y-axis. What we are talking about here are linear equations. This means they graph straight lines. Let's now begin to think about creating tables of values for straight line graphs. For example, let's create a table of values for one of our equations, y is equal to 2x, to understand how the rate of change remains constant. For example, for y is equal to 2x, when x is equal to 0, y is equal to 0 multiplied by 2. This is equal to 0. Next, when x is equal to 1, y is equal to 1 multiplied by 2. This is equal to 2. Finally, when x is equal to 2, y is equal to 2 multiplied by 2. This is equal to 4. Notice how as x increases by 1, y increases by 2. This constant rate of change is determined by m, which is 2 in this case. The straight line shape emerges because the relationship between x and y is consistent. Our final point of learning is how to work out the y-intercept. Firstly, when x is equal to 0, for y is equal to 2x, y is equal to 0. This means that the line intersects the y-axis at 0, 0. Secondly, for y is equal to x plus 5, if x is equal to 0, then y is equal to 5. This means that the line intersects the y-axis at 0, 5. And lastly, for y is equal to 4x plus 7, if x is equal to 0, then y is equal to 7. This means that the line intersects the y-axis at 0, 7. The value of c in the equation, y is equal to mx plus c, gives us the y-intercept. This shows us where the line crosses the y-axis. We've seen how different linear equations take the form y is equal to mx plus c, where m is the gradient and c is the y-intercept. By plotting these graphs and creating tables of values, we've learned how the rate of change remains constant and how these properties help to define the straight line shape. Next, we could explore how to calculate the gradient and intercept if given a graph, and look into how these concepts apply in real-life scenarios, such as business or physics. Consider the equation of a line given as y is equal to 2x plus 3. First, identify the slope, otherwise termed the gradient, and the y-intercept from the equation. Here, the slope, m, is 2 and the y-intercept, c, is 3. Next, on a coordinate plane, plot the y-intercept. This is the point where the line crosses the y-axis, which is at 0, 3. Next, use the slope to find another point on the line. The slope of 2 means that for every 1 unit you move to the right along the x-axis, you move 2 units up along the y-axis. Starting from 0, 3, if you move 1 unit to the right to x equals 1, you move up 2 units to y is equal to 5. This gives you another point, 1, 5. Finally, draw a straight line through the points 0, 3 and 1, 5. Now let's say you are shown part of a graph with a straight line that passed through the points 2, 4 and 4, 8. Step 1 would be to determine the slope or gradient. The formula for the slope is the slope is equal to the change in y divided by the change in x. Here the change in y is 8 minus 4. This is 4. The change in x is 4 minus 2. This equals 2. So the slope m is equal to 4 divided by 2. This is equal to 2. Next, use one of the points to find the y-intercept. Let's use the point 2, 4. Substitute x is equal to 2. Y is equal to 4 and m is equal to 2 into the equation. Y is equal to mx plus c. The substituted equation would be 4 is equal to 2 multiplied by 2 plus c. This simplifies to 4 is equal to 4 plus c. Therefore, c is equal to 0. Hence, the equation of the line is y is equal to 2x. By working through these examples, you can see how to identify the slope and y-intercept from an equation, as well as how to derive an equation from a graph. With practice, these techniques will become second nature, making it easier to tackle a variety of problems involving straight-line graphs. In today's lesson, we explored the form of straight-line graphs and their basic properties. We began by recognizing simple line graphs and observing that they all follow the general form y is equal to mx plus c. Here, m represents the gradient, indicating the rate of change, and c represents the y-intercept, the point where the line crosses the y-axis. We created tables of values to illustrate how the relationship between x and y remains consistent, reinforcing the concept of a constant rate of change defined by the gradient. We then examined the y-intercepts of our example equations, taking note of how different values of c shift the point where each line intersects the y-axis. By understanding these key properties, we reinforce the importance of linear equations in graph form. Recognizing the gradient and y-intercept allows us to visually interpret and analyze data, solve real-world problems, and understand relationships between variables. This foundational knowledge paves the way for more advanced topics, where these concepts can be applied in various real-life scenarios, such as business or physics. Overall, we've learned how to identify and work with straight-line graphs, a crucial skill in algebra and beyond. Watch the rest of the GCSE Maths course at Sophos Education.